Let's look at questions 16 through 20 of the MCA practice test. Problem number 16 says use the graph below to answer question 16. All of Tyler's DVDs and videotapes are on a shelf. The inequality of D plus 1.7V is less than or equal to 34 represents the number of DVDs, D, and videotapes V that the shelf can hold. He owns fewer videotapes than DVDs, represented by the inequality V less than D. The possible combinations of Tyler's DVDs and videotapes that the shelf can hold are found in which region of the graph? Well, we know that the equation has to be less than or equal to 34. So if I pick anything up here, we can go forever in whatever direction we want, so we're unlimited. So I would say 3 and 4 region are automatically closed out. That leaves us with 1 and 2. Not to mention it has to be below or less than or equal to the 34. So we know we're below that line. It also says that the V has to be less than D. So if I'm looking at this, this is V, this axis, the y-axis, and this is D, the x-axis. And they're saying V has to be less than D. Well, this line right here represents where V is equal to D. If V is less than, or your videos is less than DVD, it means I have to be below that line. So I am guessing it's quadrant 1. Let's just verify real quick by picking some kind of point. Pick 10, 5. We got the coordinate 10, comma 5, where 10 is our number of DVDs and 5 is our number of videotapes. Does this part hold true? Is 5 less than 10? Yes, so we're okay there. Let's test this part now. Is 10 our number of DVDs plus 1.7 times 5 less than or equal to 34? If you do that on your calculator, you end up getting that this is 18.5, which is in fact less than or equal to 34. So I would say 1 is in fact the region we are looking for. Let's look at 17. A contractor wants to lay an underground telephone cable across a field starting at the telephone pole. T. T is right here, this point right here. The cable should run parallel to the water line. Which of these is an equation for the line that the telephone cable should lie on? They want them to run parallel, not perpendicular. This would be perpendicular, where they run perpendicular to each other. Parallel is something similar to that. Well, if we're talking about parallel lines, then we are talking about equal slopes. Slopes. And slope is rise over run. And that's equal to your slope. So let's go through and find the slope of our water line to begin with. I'm going to use this point here because it's on a line and a point that matches up, and this one right here because it also lines up with a specific point, so it's easier to find. I know to go down and over. I have to go down 2 units and over 3 units. That means my rise in this case is actually a fall of -2, and I have to run over 3. So my slope has to be equal, right? If they're parallel, then that means my slope has to be -2/3. That crosses out A and it crosses out B, leaves me with either C or D. Well, the only thing different between these two is the 4 and the 6, which we call our y-intercept. Where does it intercept or intersect the y-axis? Well, the original water line, I know for a fact, goes up and it intersects at 4. Well, my line has to be parallel. If I go to draw an eyeball it, a line that's parallel, somewhat parallel to the water line, I get something that looks like that, which means it can't be 4. 4 can't be our answer because it's not going to be parallel otherwise. It looks like 6 is my best possibility. So 4 I know doesn't work. That means my answer is going to be D as in dog, because my y-intercept is 6 right here, and my slope has to be -2/3. It has to be equal to because they're parallel. Question number 18. The heights in inches of the 15 students in Jared's grade 11 science classes are, and then they give you the 15 numbers. What is the upper quartile Q3 of these data? Quartile 3. Quartile 1 is our 25th percentile. Quartile 2 is our 50th percentile, otherwise known as our median, or the middle number. And quartile 3 is our 75th percentile, or what we call third quartile. Couple different ways of doing this. One, if I want to look at the actual numbers themselves, the first thing you're going to have to do is make sure that you put them in numerical order from smallest to greatest. Notice they do not do that and they try to trick you. So you want to make sure you put them in numerical order from smallest to greatest to begin with. Your median is your middle number. So I'm going to go through, if I have 15 pieces of data, that means my middle number is going to be the eighth. 1, 2, 3, 4, 5, 6, 7, 8. 68 is my median. The quartile is the median of the lower half. Well, here's my lower half. I have 1, 2, 3, 4, 5, 6, 7. 7 pieces of data. So this is the median of my lower half. So that's going to be my Q3. Just like the median, which would be my fourth number out of 7, this is my Q1, or my 25th percentile. So my 75th percentile, or my Q3, is going to be 70, which is D as in dog. You can also do this on your calculator. Go to Stat, Edit, and in List 1, go ahead and put the numbers in. If you want to put them so that they are numerical order from ascending, or from smallest to greatest, all you have to do is, after you've typed them in, and I've got them all in there already, just hit Stat. Sort A means sort ascending, so I hit number 2, and I say list 1, so second, number 1, and all it says is done. Now when you go back to Stat, Edit, you'll look in list 1, there they are. They're in numerical order if you ever wanted to rewrite those instead of having to try to figure them out. Otherwise, you can just type them into list 1 and go right to Stat, Calculate, one variable stats. It'll automatically look at list 1 unless you tell it to otherwise, and then it gives you a whole slew of data. X bar is 67.66, that's my mean. These are my standard deviations. N is my 15, that means there's 15 pieces of data. If I scroll all the way down to the bottom, I get my 5-number summary, which comes into play for box and whiskers. Here it is. The minimum is 60. My Q1, or 25th percentile, is 66. My median, or the 50th percentile, is 68. Q3 is my 75th, and there's my max. Again, there it is right there. 70 is my Q3, and there's my answer for number 18. Let's look at 19. Use the table below to answer question 19. Number of student car accidents in the school parking lot by month. They've got September had 2, October 3, November had 5, December had 7, January had 8, and February had 4. What conclusion can be made from the above data on 6 months of accidents? The median number of accidents is 6. Well, again, let's look at this. Be careful because they're not in numerical order. Look at number 4 actually belongs up here. So I'm going to rewrite that. 2, 3, 4, 5, 7, 8. This time I have an even number, so my median falls halfway between 4 and 5, which is 4.5, or 4 plus 5 cut in half, the average between those two numbers, so 4.5. That's my median, not 6. So A won't work. Part B, on average, more accidents happen in September and October than January and February. All right, so let's look at September and October. September had 2, October had 3. So 2 plus 3 cut in half. How does that compare, we'll find out, to January and February? Here's January and February. So 8 plus 4 cut in half. 5 over 2 is 2.5. 8 plus 4 is 12 over 2, which is 6. 2.5 is less than 6, or September and October is less than January, February. They say that it is more students. We found that it is actually less on average, so B doesn't work. Let's look at C now. On average, again, more accidents happen in December, January, and February. This time we're looking at December, January, and February. So 7 plus 8 plus 4 divided by 3 if I'm going to find the average. How does that compare to September, October, and November, which is these 3? 2 plus 3 plus 5. And again, divide by 3. So here I get, for number 19, the first part, I get 7 plus 8 plus 4, which is going to do this on your calculator, and I would really suggest you put this in the top part, then hit enter or put it in parentheses and divide by 3, and you get 6 and a third. Then do 2 plus 3 plus 5, or 10 divided by 3, which is 3 and a third. Well, 6 and a third is greater than 3 and a third. So does December, January, and February have more than September, October, and November? Yes. So I'm guessing my answer is C. Let's just verify real quick. D is not a possibility. More students drive to school as the school year goes on. This is about the number of accidents, not about how many students drive to school as the year goes on. So D is not going to work as well. Neither did A or B. So my best answer was C. Again, read through all your possibilities before you move on to the next problem. Number 20. Use the graph below to answer question 20. And you got Aiden's bike trips. The scatter plot shows the time and distance that Aiden rode his bike on several trips. Using the scatter plot and assuming a linear relationship, about how many miles would Aiden travel if he rode for 175 miles? Key here, using a linear relationship, meaning we're looking for a line of best fit. So I'm looking at this data. This is a bunch of scatter points. This is a bunch of data that he gathered over time. Let's go through and predict using a line. Just kind of eyeball it, and a lot of times it helps just to kind of draw it in. I would say that's probably a pretty good line of best fit. Goes through most points and is your linear relationship like they talked about. They specifically asked us to look at 175 minutes, and they want to know how far will he go in distance for 175 minutes. So we can take out our eyeball again, or our ruler in our eyeballs, and just use it to predict 175 up to that line, and then follow that line straight across, and that gets you to 40. So 40 I would use as my predictor, which is letter C. In this case, it's what we call a line of best fit, or a least squares regression line. They're just testing to make sure you understand how a scatter plot works and how you can predict data off of the scatter plot. That does practice problems 16 through 20. Hope it helped.